Today's video is on rate of turn indicator, as sometimes popularly known as ROTI or ROTI. And the rate of turn indicator is a type of gyro which indicates a vessel's rate of turn in degrees per minute. Now, before you watch this video, please make sure that you watch my previous videos on gyro compass, because this concept also uses the principle of a gyro compass, or a gyroscope rather, not a compass but a gyroscope. So it's essential that you understand how a gyroscope works, otherwise it will be difficult for you to understand how a rate of turn indicator works. So please make sure you watch those videos. I've given the links in the description section below. All right, the rate of turn indicator provides useful information while maneuvering in confined areas, and this is particularly so for large vessels, where they are also sometimes referred to as rate gyros. Now, as per the SOLAS regulation, or here I'm discussing the marine order regulation, as per the regulations, all ships over 50,000 gross tonnage shall have a rate of turn indicator. Now, to understand how a rate of turn indicator works, or a ROTI works, you have to understand the principle of a free turning gyroscope. Now, as you know, the free turning gyroscope has three axes of freedom: the spin axis, the tilt axis, and the drift axis, or the spin axis, the horizontal axis, and the vertical axis. However, when a gyroscope is used for a rate of turn indicator, it has only two axes of freedom. One axis of freedom is blocked. I'll show you which one it is. Now, this is the variation from the normal gyro, as the gyroscope that is used in a rate of turn indicator is given partial freedom of movement in only two axes. One is the spin axis that you see the yellow disc rotating, that is the spin axis, and the second one is the tilt axis. So the freedom of movement in the drift axis, or the azimuth, is restrained. Right, you can see the restriction here. This is the axis which is restrained. In other words, the gyroscope is restricted to move about in the horizontal plane. So the principle is such that when the vessel turns, the gyro suffers an acceleration force in the horizontal plane. As the movement in the horizontal plane is restricted, the gyro feels a horizontal push. This horizontal push, and so the resultant precession, causes the gyro to tilt. All right, if you don't know what precession is, please watch my previous video. Now you can see there are springs located above and below the gyroscope. Now when the gyroscope feels the horizontal push and the resultant precession causes the gyro to tilt, these springs that are located above and below the gyro, now hence the tilt that now causes precession in the azimuth, or back to the horizontal plane. So now imagine these springs being pushed, and now because the springs are so taut, it cannot be pushed. The spring, because it experiences or it feels that push from the axis of the gyro, it actually pushes back, equaling a force, equal and opposite force, it pushes back. As the change in azimuth is entirely due to the turning of the vessel and not due to other gyroscopic or earth properties, this precession is directly proportional to the rate of turn. A suitable timing device can be used, and the system can then display the rate of turn per minute. In the same video, you can see I am showing you from the view of the axis of spin, and then I will also show you the formula for calculating the rate of turn gyro. So here is the ship turning. It applies the force to end of spin axis. Because of the spring that restricts the movement of the gyro axis, the gyro experiences an equal and opposite force back from the spring, which results in a resultant tilt, which is equal to the force experienced, and this force is equal to the rate of the turn of the ship, and that is how it measures the ship turning force. All right, Now if we move on, the formula for the rate of turn of gyro can also be calculated. The rate of turn is directly proportional to the rate of precession, and the formula is, as you see on your screens, it's 0.96 multiplied by the speed of the vessel in knots divided by the turning circle radius. The radius of the turning circle will then give you the rate of turn at which the vessel should be making that turn. Now this information is very useful when the vessel is maneuvering in narrow channels, or it is making alterations of broad or large value of courses, or it is making course alterations between two land masses. Here, knowing the rate of turn in degrees per minute is useful, especially even as a passage plan information. So you should be calculating this information and putting down on your passage plans so that you can monitor the vessel's rate of turn when the vessel is making such turns. So the rate of turn gyros are very useful when gauging and drawing constant radius turns on the chart, calculation of wheel over point, achieving a constant radius turn, making allowance for wind and tide, and also indicating the rate of turn of the vessel's heading while maneuvering the vessel around tight spot or berthing, etc. Rate of turn indicator has its use on all types of marine crafts and can enhance both the safety of navigation and collision avoidance. On vessels for inland waterways, the rate of turn indicator has the task of assisting radar navigation by measuring and indicating the swing or the rate of turn of the ship to port and starboard. In conjunction with course keeping devices or such as autopilot, the rate gyro as sensor system provides the turning rate reference. On seagoing ships, the rate of turn indicator serves primarily as a navigating support for sensing and indicating the swing. This may be particularly useful when used with the EGDIS system, or EGDIS rather, for course alterations in enclosed water like channels, rivers, etc. For seagoing vessels of more than 50,000 gross tonnage, as I mentioned before, it is a requirement that this equipment is carried on board. Repeaters may also be fitted to the vessel at different maneuvering positions to indicate the vessel's rate of turn. And when we say different maneuvering positions, we mean the bridge wings, port and starboard. Hence, it is worth noting that some modern gyro compasses will provide the rate of turn output as a standard additional feature, and so a separate rate of turn gyro does not need to be employed by the vessel.